In this video, we'll look at some more examples of using integration by parts, specifically for integrals where the integrand is only one function. Now this seems a little bit strange because our original motivation for integration by parts was we were trying to find something equivalent to a product rule. So in differentiation, we had a formula or a rule to help us differentiate a product of functions, and we were looking for a similar thing with integration. So why would we need to use this product rule or integration by parts to integrate only one function? Well, let's have a look at the first example here, the integral of log x. Now, yes, there's only one function, but we don't know how to integrate log x. Now, we have the advantage of knowing that we need to use integration by parts to do this. So what we need to do is we need to look at this and think of it in a different way. We need to think of the integrand as not just log x, but actually 1 times log x. And the reason for this is now I've actually introduced in a second function. So just like the number 5 is a prime number and can only be written as 5 times 1, log x is sort of like a prime function. It can only be written as 1 times log x. Unlike something like x², for example, which could be written as x times x. That wouldn't be a prime function, so to speak. So now that we have this, we need to make our choices of what's going to be integrated and what's going to be differentiated. Or in other words, what are we choosing as u and what are we choosing as v dash. Now obviously we're not going to choose v dash to be log x because that's what we're trying to do. We're trying to integrate log x. So that has to be u. We want to differentiate log x. And in doing that, we get 1 on x, which means that v dash has to be 1 and v is going to be x. So now we can go ahead and apply our integration by parts formula, which tells us that it's u times v. So that's going to be log x times x, and I'll write the x out the front, minus the integral of u dash times v, which is 1 on x times x. Now 1 on x times x is 1, and when I integrate 1, I'm just going to be left with x. So it's x log x minus x plus c. Now if we wanted to, we could factor out an x here and have log x minus 1 times x. And that would be our final answer. The second example is looking at the integral of the inverse tan function. Now again, in this situation, we only have one function, but we're going to think of this as the integral of 1 times tan inverse. And once again, we're going to choose the function to differentiate to be tan inverse, because we don't know how to integrate that. That's what we're actually trying to do. And when we differentiate that, we get 1 over 1 plus x². That means v dash is equal to 1 and v is equal to x. Now we go ahead and use our integration by parts formula, which tells us that it's u times v, so x times tan inverse x, minus the integral of u dash times v. So that's going to be 1 over 1 plus x² times x. Now for that integral, what we're going to do is we're going to write that as one function, or one fraction I should say, x over 1 plus x². And hopefully you're a bit familiar with how to do these. This is something that you would find in just the advanced course. This is going to be a log. So if I times the top by 2 and then divide by 2 or times by a half, now I have a fraction where the denominator is a function and the numerator is its derivative. And this is of course a log function. So this is going to be x tan inverse x minus a half times log of the denominator, which is 1 plus x² plus c. And that is the final answer.